Peter?
Yes, I got it. Hello guys, welcome to null OS combined meetup again. And I hope many of you people know already about the null and OS chapters. And I would like to say again what we exactly about it. And null community is one of the open security community. We conduct monthly meetups and hands-on sessions like Bachao, Hamla, and Pulia. But because of COVID-19, right now we are not able to conduct this kind of hands-on sessions. But we are still going with meetups for security conference, which we conduct every month. It's going good, and I would like to give my co-host Vandana to talk. Vandana.
Thanks, Mr. IoT. Hi, everyone. Welcome to today's meet. And as all of you know that we are in the lockdown, uh, we are all remote. So we are also doing these meetups online, and probably in the coming months also we will be going online only. So in today's session, we have three speakers. The first one is Omkar, then Swapnil, and Akash. So first we will start with Omkar. You can look at all the topics on Null Bangalore site, and similarly Null's, or I should say Null Swachlit site and Owasp Bangalore meetup page. You can live stream. You can actually tune in to the link, which is unique for the Owasp and Null Bangalore YouTube channel. For all the older videos also, you can just go back and listen to them. They're all there. They're all going to be there because we had questions in the past that whether the sessions are recorded, whether you're going to get the links. And similarly for presentation, speakers have uploaded the um, presentations on the Null Bangalore site. So you can download it from there. If you still have any questions, please feel free to reach out to us. And about Owasp Bangalore, Owasp is an open web application security project. It's a community wherein people connect, share knowledge. There are a lot of chapters across the world. If you are in any specific area and you want to attend, when the in-person meetup start or when everything just gets open and we start traveling, so you can join that chapter meet at that particular time. Also, we have certain projects which we can take help from. There are multiple projects. You just go to oasp.org and go to project. You'll be able to see all the projects. Now, I would like to give it over to Omkar so that he can start sharing his screen and start talking about today's topic. So, Omkar, good
Yeah,
morning.
good morning. Thanks, Vandana. Thanks, Veera, for giving me this opportunity to uh, present mm, on Null Meetup. So I'll start. I'll share my screen. Yeah, I hope you guys can see my screen. Please let me know, Vandana and Veera.
Absolutely.
Yeah.
Yeah, we can see that.
Okay. So today I'm going to talk about a DNS primer. So my topic name is DNS primer. So here I'll be talking about all the basic fundamentals of DNS that every security professional should know. So let's start. So I will quickly introduce about myself. So my name is Omkar Kumbhar, and currently I'm working as an associate solution advisor for Deloitte in cybersecurity practice. And recently I moved into cybersecurity domain. So before that, I was working as a Salesforce developer for past 4+ years. And here in this PPT, I have mentioned my Twitter handle at the rate Kumbharomka07, and also I provided my LinkedIn profile link, so you can connect me on LinkedIn, on Twitter as well. And yeah, you can ask me any questions if you have after this session regarding my presentation. Okay, so now let's start about the exact topic. Okay, So yeah, so first we'll understand what is DNS. So I hope everybody is already knowing what DNS is, but still I will go from scratch and will explain about it. So DNS simply stands for domain name system, which provides a naming structure for online web resources. So in simple terms, DNS maps domain names to respective IP addresses, and also vice versa, it maps respective IP addresses to its associated domain names. So for example, if you have a domain name like www.example.com, then the DNS protocol can give you a respective IP address associated with that domain. Okay. So now I'll tell you a little bit about its history. So actually it's created by Paul Mokapetris at UC Irvine in 1983. So before DNS was invented, people used to map names to IP addresses by sharing big text file called as host.txt. So this file host.txt also you can in today's world also you can see this file in all the operating systems, Linux, Windows. So in Linux you can find this file under etc directory, and this file is still present where sometimes we do manually entry for several domain names. Yeah. So, and the DNS protocol generally uses UDP and it listens on port number 53. Okay. So sometimes it uses TCP as well if the data is greater than 512 bytes. So the great example of this is zone transfer. So yeah, so zone transfer is a operation which actually which is actually a huge operation where the data is greater than 512 bytes. So in that case, DNS uses TCP protocol. Yeah, so this is all about the overview of the DNS. Now let's move ahead and understand about the DNS hierarchy. So the very first thing in DNS hierarchy is the root domain. Yeah, so which is denoted by dot. So after root domain, there are top level domains. For example, .com, .edu, .net, .org. So these are called as a top level domains. So after top level domains, there is a second level domain. Okay. Yeah. So after second level domain, there are subdomains. For example, dev, API, staging, QA. So these are called as a subdomains. And after subdomains, there is actual host name. So if we consider the fully qualified domain name, it would be a www.api.example.com if we take an example. So here this is called as a fully qualified domain name, but the one thing to notice here is, so this trailing dot is required at the end. So if you see at the bottom, the fully qualified domain name is www.api.example.com dot. So unless and until you have this trailing dot at the end, you cannot call it as a fully qualified domain name. So generally, when we say domain name, we just say that www.google.com, www.youtube.com. So these are called as a partially qualified domain name. And if we add a trailing dot to that domain name, then it will become a fully qualified domain name. Yeah, so this is all about DNS hierarchy. Now we'll go ahead and we'll understand what are the DNS query types. So DNS query is nothing but DNS request. So there are different types of DNS requests. So mainly there are four types of DNS requests. So first is forward request, reverse request, recursive, and iterative. So forward request is very simple. We use it for our general purpose to get the IP address. So in forward request, your client just asks for IP address for given domain. So for example, if you say that give me IP address of www.google.com, you are doing a forward query or forward request. Now, what is reverse request? So reverse query or reverse request is it just asks for domain name for given IP address. So if you are saying that, hey, the IP address is a.b.c.d, let's say, and give me the associated domain name with this IP address, then that query can be considered as a reverse query. A third and fourth queries are very important, and I'm going to talk more about this in remaining session. Recursive query and iterative query. So in recursive query, client asks the server to do all the resolution work on client's behalf and interested only in answer. For example, suppose I am a client, my local machine, whether it be a laptop or desktop, if I am asking my local DNS server, hey, give me the IP address of www.google.com and just provide me the answer, just provide me the IP address and do all the name resolution work on your own. Means here client will not take any part in name resolution process. Your DNS server will do the name resolution process and it will provide you the respective IP address. So this type of query is called as recursive query. The next thing is iterative query. So iterative query is completely opposite of recursive query. Okay, in this thing, in iterative request, client takes part in name resolution process, where a DNS server tells client, hey, I have this much information. To know more information, connect with another DNS server. So then again, client will go and connect with another DNS server and get the information. So you will understand this type of recursive and iterative queries better when I will talk about the name resolution process in detail. Okay. So the next thing is DNS response types. So what are the DNS response types? So there are two main response types. One is authoritative and second is a non-authoritative response. So authoritative response is nothing but the response which comes directly from the name server, which has authority for the record in question. So let's take an example of google.com. Suppose your computer is directly asking google.com's DNS server to provide the IP address for www.google.com, and google.com's DNS server is directly giving you answer for the question www.google.com, then that response can be considered as an authoritative response because Google's DNS server has authority over the google.com domain name and all its information. Okay, so this type of response is called as authoritative response. So here in my lab, I have configured authoritative DNS server for example.com. So if my client, my desktop can ask the example.com DNS server to provide the IP address for www.example.com, I will get authoritative response. So I will show you that in later slides. So the next thing is non-authoritative response. So generally, whenever we do DNS resolution by using tools like NSLOOKUP or host, we mostly get non-authoritative response. Okay, because this response comes from another server or from cache. So what do you mean by another server? So let's take an example of www.google.com, where my client machine, my laptop is going to ask my local DNS server, hey, give me IP address of www.google.com. So my local DNS server will not have authority over google.com's domain information. So what my DNS server will do, it will go out, it will ask other servers, and it will get the information. Okay, so this type of response is called as non-authoritative response. So I have given the example here. If your local DNS server is giving you answer for, let's say, google.com or any other domain, then that can be considered as non-authoritative response. Now you look at DNS uh, query. So how the DNS query actually looks like. So actually, as I told you, I have configured local authoritative name server, and I have captured this DNS request and response from my lab. Okay, so this is I have a screenshot I've taken from a Wireshark traffic. So if you look at this query, here my source, it is my client machine. Actually, it's a Kali machine, 192.168.30.132. It is doing a DNS request, okay, to my DNS server. So 192.168.30.143 is my local DNS server. So it is asking the query like, hey, give me a IP address of www.example.com. So the key things you can notice here is, so first thing I've highlighted in red is recursion desired. This flag is set to 1 in the DNS request packet. So I will explain you this recursion desired thing in when we look at the name resolution process in detail. So just remember this, the recursion desired flag is set to 1. That means my client is doing a recursive query. And here the next thing is question it is asking that the count is set to 1. That means this packet is a DNS query packet. So in the queries, you can see it is asking a question, hey, give me IP address or a record type or the host address for www.example.com. Okay, so this is how the standard DNS query look like. So now let's have a look the DNS response. See, so here now my local DNS server is replying you back with the IP address. So if you see at the first highlighted flag here, that is response flag is set to 1 because this message is a response message. It is giving you an answer for your question. The second most important thing, the authoritative flag is also set to 1. So what do you mean by that? The answer is authoritative because the server who is giving you answer has an authority for the domain you have asked. Okay, and at that bottom, if you can see, you have asked one question, you have provided with one answer, and there are additional two things, authority resource records and additional resource records, that has also provided by your DNS server. So let's have a look in detail. So if you see, the answer has been provided over in this DNS response packet. See, www.example.com type is A and the address is 192.168.30.1. And along with this, the extra information is provided by the DNS server. Authoritative name servers are ns1.example.com and ns2.example.com, and the IP addresses of ns1 and ns2example.com. So these additional information is provided by DNS server along with the answer. So this is how a typical DNS query and response look like. Now let's go ahead and understand some key terminologies about DNS, that is DNS cache, DNS server, and DNS resolver. So many of you or many people means get confused in these terms. Okay, so what is DNS cache and what is DNS server and DNS resolver. So let's see, look at it one by one. So the first thing is DNS cache. So DNS cache is a list of domain names and IPs that has been resolved recently. So you can find DNS cache on your local machine as well. If you go ahead, open the command prompt on Windows, and if you type command like ifconfig space / display DNS, if you give that command, you will see a DNS cache. Okay, which will contain list of all the domain names and IP address that has been resolved as of now. So the DNS cache is present on your local machine as well as it is present on uh, DNS server as well. Okay, so now what is DNS server? So DNS server is a server which actually serves the DNS request to clients. So it can be cache only DNS server or it can be authoritative name server. So we will see in more detail what are the different DNS server configurations. So DNS server, if it is a let's see, if it is a cache only DNS server, it will just perform a recursive query, and if it is an authoritative name server, it it will hold authoritative information for particular zone or domain. Okay, and the third thing is DNS resolver. So DNS resolver is nothing but DNS clients. So it may be your laptop or desktop, your computer, which is asking for a which is asking DNS query. Okay, so these are nothing but DNS clients. They make iterative or recursive queries. Okay, so now let's have a look at DNS server configuration. So there are two types of DNS server configurations. First is cache only DNS server, and second is authoritative DNS server, which is sometimes called as master slave configuration as well. So many times, generally you will see cache only DNS server. So most of the times in your company as well, the cache only DNS server will be configured. In your ISP, most of the times the cache only DNS server will configure. So what is cache only DNS server? It will just it doesn't hold any authoritative information of its own. It just goes ahead and relies on the information obtained by recursion. For example, if your local DNS server is configured as cache only, and if you ask your DNS server, give me the IP address of www.google.com, it will go outside, ask other DNS servers, and will get the information uh, and will give it back to you. So this type of DNS server is called as cache only. And the second one is authoritative DNS server, which actually holds authoritative information for certain resources. So for example, if you consider google.com's DNS server, so that will actually hold all the information related to DNS, google.com's subdomains and its respective IP addresses. So that's why it can be called as authoritative DNS server, because it has authority over google.com domain, and it has all the subdomains domain information regarding google.com. So in this DNS server, authoritative DNS server configuration, there are two things, uh, master and slave. So master is called as primary server as well, where the master server which holds all the data related to particular zone, and there is a slave server also called as secondary server, which pulls the zone information from master server for backup and redundancy. So whenever any new subdomain or new records is added into the master or primary server, the secondary server will pull the zone information from master server, and it will store in it for backup. So in sometimes, let's say if master server goes down, then secondary server can answers the requests of DNS client. Okay, so these are the two main DNS server configurations. So now, uh, enough with the DNS terminologies. Now we'll understand how the actual DNS resolution process will look like. Okay, so let's assume on your laptop or desktop, the user is entering www.example.com in browser. Then what your client machine or your local machine will first do, it will check its cache. Okay, it will check if the client machine already has answer for www.example.com. If it don't find the answer in cache, it will check the hosts.txt file if there is any manual entry created for www.example.com. If it finds, then it will give it back. If it doesn't find, then it will go ahead and do recursive query to local DNS server. Now, as I have told you before, there are two types of queries, most important, recursive and iterative. So here the client will do recursive query. So what it will say in recursive query is that, hey, DNS server, I want IP address of www.example.com. Do all the name resolution process on my behalf and just give me the answer. I'm only interested in the answer. I'm only interested in IP address. I'm not going to take part in name resolution process. So this type of query is called as recursive query. So once the DNS server receives this query, DNS server will check its own cache if it already have or if it already has the answer. If it has, it will give it back. If now we are assuming that it doesn't have answer for the question you have asked, so it will check its local root server name server file. So on DNS in DNS server, so there is already there is one file which has all the information related to root name servers. So in if you uh, take the Linux example, you will find a name.ca file in the DNS server, which comes by default with DNS bind package. So this file contains all the information of root name servers. Okay, so now the local DNS server don't have a answer for www.example.com. It will check this name.ca file and it will fetch the root name server information, and it will go ahead and will query root name server. Okay, so now the local DNS server will send iterative query to root name server. So now notice here the local DNS server is now doing iterative query because this local DNS server is taking part in the name resolution process. Okay, it will do iterative query to root name server and ask, can you give me answer for www.example.com? The root name server will say, hey, I don't know the exact answer for www.example.com, but I can give you the name server's address for .com. So root name server will have information about top level domains. So it will give you back the name server for .com. So once your local DNS server gets the name server for .com, it caches it for future use, and then again send the iterative query to .com server and asks that, hey .com server, do you have answer for www.example.com? Now your .com name server will say that, hey, I don't know answer for www.example.com, but I can provide you the name server address for example.com. Okay, because the .com name server will have information about all the second level domains. Okay, like example.com, as we saw, second level domain like Google, YouTube, Facebook, these are all second level domains. So it will give a name server for example.com. Then the local DNS server will cache the name server's address for future use, and then it will go ahead and will ask the it will do iterative query to example.com name server and will ask, hey, can you give me IP address of www.example.com? Now example.com name server will say that, yes, I have answer for the question you are asked. It will check its local zone information. There, this example.com name server will find an entry for www.example.com, and let's assume the IP address is a.b.c.d, and it finds the answer. It will give it back to the local DNS server. Hey, this is the IP address for www.example.com. Once your local DNS server gets this answer, it will cache it in its memory, or it will cache it locally and for future use, and then it will give this IP address back to the client. So once client gets this IP address, it will your client also cache it for future use, and then once the client gets the IP address, it will do normal HTTP request to resolve IP address. Okay, so this is how a typical name resolution process look like. Okay, so I hope you have understood this. So now let's look at what do you mean by resource record. So resource record, which actually builds up the zone file. It's a unit of information entry in DNS zone files. Okay. So actually every DNS server have its zone file, and most probably in authoritative name server, you will find a zone file which actually contains the all the information related to that domain. And so the zone file, the information stored in zone file in the form of resource record. So here I have shown you a example of resource record, how it is how it look like. So this is a typical resource record will look like. So here uh, generally it has a 5 fields. The first field is the owner, which is actually the domain name. So here the domain name is example.com. The second field is TTL, time to leave, which actually tells how long this zone record is valid. The third thing is a class, which describes you represents the protocol family, and this is common for pretty much all resource record. IN is a protocol family, and the fourth thing is a record type. Okay, so what type of data this resource record is holding? So it is holding a record type in this example. A record type is nothing but the IP address. And after type, there is a last field is R data, which is called as a resource data, which actually holds the information. So this is how the typical resource record is look like. So now let's go ahead and understand what are the different DNS record types. So there are a lot of record types available, but we will look at the most common record types. Okay. So the very first is the A record type, uh, which holds the IPv4 address. Okay. The second record type is AAAA. Okay, 4 times A, which holds IPv6 address. The third is CNAME, which is called as canonical name. So this record type hold alias information for particular domain name. Fourth record type is a MX, which is mail transfer agents for the domain, which means which actually holds a mail server information for particular domain. Next thing is a NS record type, which actually holds authoritative name server information for particular domain. Then there is a PTR record type, which is called as a pointer record. So this record generally used when you when a client wants or client do a reverse query. Sorry, when client do reverse query, if a client provides IP address and it wants domain name as answer, then this pointer record is used for reverse lookup. The next thing is SOA record, which is called as source of authority record, which generally has an overview of that particular domain, which contains what the domain name is, what is the admin email address for that DNS server, what is the expiry time, what is the refresh time. So all this information is the SOA record contains all this information. And the next thing is AXFR, which is also very important, which is called as authoritative zone transfer record type. So this record type is used when client wants to initiate a zone transfer. So look at it what the zone transfer is in next slide. So these are the common record types I have mentioned here, because these are the record types we mostly see in our day-to-day job. So now let's move further and look at what is zone transfer. So zone transfer is a process of retrieving a zone data from another authoritative server. That means zone is nothing but, let's say if you have an authoritative name server configured. In my case, I have configured example.com name server. So in that name server, I will have a zone file. In that zone file, I have mentioned all the domain names related to example.com and its respective IP address in the forms of resource records we saw earlier. So whenever a secondary server wants to pull this information, the secondary server initiates zone transfer. Okay. So usually it is initiated by secondary or slave server for backup and redundancy purpose. So this operation takes place over TCP because the data is usually greater than 512 bytes. So generally, as I have told in first slide, generally DNS uses UTP uh, for giving a response, but this zone transfer operation is generally is used. The data is greater than 512 bytes, so it happens over TCP. And here the client sends a query of AXFR. Okay, when client sends a query of AXFR, that means the client is asking for zone transfer. But here there is one security risk involved. If anyone can do zone transfer from your DNS server, anyone means any client machine can do zone transfer from your DNS server, then that's a very bad thing. And it's a very good thing for attacker, because if attacker can do zone transfer from your DNS server, they will get all the information related to your domain subdomains for your zone, and also they will get all the internal IP addresses which you are using for your domains. Okay, so this is a very bad thing, and this will help a lot the attacker in the reconnaissance sorry, reconnaissance process. So so that's why the zone transfer should only be allowed by approved systems only. Okay, so now let's go ahead and let's have a look at the demo. So here in this demo, I have shown how to perform DNS enumeration, how to perform DNS brute forcing, how to initiate a zone transfer. So here I have in this PPT, I have attached this one file, DNS enumeration commands.txt. Here you will get all the commands I have used in this demo. So now let's go ahead and have a look at the demo. So here, first I'm using a dig tool. So here I'm using a client machine, a Kali machine as a client, and I've locally configured example.com's DNS server, okay, in my lab. So what I did is here, I gave a dig command example.com, then it provided me this much information. So it provided me the IP address of example.com, what are the name servers of example.com and its IP addresses. Now next, if I do dig example.com and if I give plus short switch, it will just give me a IP address. Okay, so I have provided the plus short to avoid the any extra information. Okay, it will just give you the exact information what you are looking for. Now here I've provided the NS switch, which is actually NS record type. So the dig server, the dig tool will ask the example.com server, give me the name servers of that domain. So it is giving you the NS1 and NS2 example.com. If I give a MX switch, it will give you the mail server information. If I give SOA switch, it will give you SOA record. If I give a C name, then it will give me a canonical name. So see, if you can see here, the actual name is services.example.com and the sss.example.com is alias. So CNAME record type asks the server, hey, give me the canonical name for this particular alias. So now hypernext, which is used to perform a reverse lookup. Here, sorry, mm, yeah. So here I'll provide IP address and I'll ask for the domain name. So if you can see, I have given IP address and the server provided me with the respective domain name. So this is how the reverse lookup can be done. Now next thing I'm going to initiate is a zone transfer. So this is dig AXFR. So AXFR is a record type I'm using to initiate zone transfer. See, so when I initiate zone transfer, it is giving me all the information related to all the subdomains of example.com and its respective IP addresses. So if you can think from attacker's perspective, if attacker can do the zone transfer, he will get all the information. So this is a very bad thing from security perspective. So only allow uh, zone transfers to only authoritative or authentic systems, I would say, or only approved system. So how to do that, we will see in this demo. So now I will show you the same thing with NS lookup, because NS lookup tool is available on Linux as well as on Windows. So the syntax is a little bit different. So let's have a look at the NS lookup as well. Yeah, I hope everybody can see my demo.
Right, we can see. So, Omkar, you're left
Yeah,
with 9 minutes. Hope
sure,
you'll be able
sure.
to complete.
Yeah, sure.
Great.
Yeah. So NS lookup, so you can see this demo later as well. So I have did the same thing. So here also you can query different uh, means you can query a different record information and you will get that. So there is also DNS enum tool which is provided in Kali Linux, which will provide you all the information in one shot, all the name servers, mail servers, and the zone transfer as well. So yeah, so there is a to do a DNS brute forcing, you can use nmap tool. So there is a DNS brute script which you can use to do DNS brute forcing. See, here you'll give all the information related to the IP address and domain name. So also there is a fierce tool built in Kali, which can be used for performing DNS brute forcing and also reverse lookup. So you can see this in my demo later as well, and you can ask if you have any questions. So this is how it will mm, perform DNS brute forcing. And also the fierce tool can be used to perform a reverse lookup by providing the IP addresses, and it will give you back the domain names respective associated with that IP addresses. So that's all. Yeah. So now let's talk about a little bit about DNS security. So if you see there is a DNS spoofing and DNS cache poisoning attack is possible. Because why this attack is possible? Because here in this attack, attacker redirects victim to malicious website by inserting false information into a DNS cache. Because DNS typically there is no way to verify the DNS data in their cache. So as of now, if you consider normal DNS protocol, there is no way to verify whether the DNS data is authentic or not. So that's why this DNS cache poisoning or spoofing can be possible. Actually, I wanted to show you this, but because of the time constraint, I couldn't. Maybe I can take a separate session on this DNS cache poisoning. That is very interesting. So to protect from this, the more secure DNS protocol is there, that is DNSSEC, which aims to resolve this problem, but it has not been widely adopted yet. So some companies or some organizations have adopted it, but not everyone has adopted it. Okay, so let's look at what is DNSSEC. So DNSSEC is a short for DNS security extensions, and which attempts to add layer of security to original design of DNS. So it protects DNS clients from populating false or forged information in their cache. Okay, so how it does that? So all answers in DNSSEC are digitally signed using public key cryptography. So we will see how this DNS sec works. So before that, we'll just understand few terminologies about DNSSEC. So the first thing is RR set. So which is called as resource record set. It is a group of records with same type. For example, if you consider there are 3 4 record a record types, and if we collect them, and if we consider the set of that, it can be called as RR set of a record type. Okay, second thing is zone signing keys. So this zone signing keys is used to sign or verify each RR set in the zone. Okay, so there is one more terminology is RR-SIG, which is called as resource record signature. So by using means this record actually contains a digital signature of RR set. So this RR set is signed with the zone signing keys, and as output the RR sig is created. The next thing is key signing keys. These key signing keys is used to sign and verify the zone signing keys. Okay, and there is a fingerprint which actually a hash or a digest of public keys. And the last terminology is in the DNSSEC is DS, delegation of signing. This record contains the hash of child zone public KSK. So I understand this little bit confusing here, but when we look at the example, you'll understand it better. So now let's have a look at how DNSSEC works. So let's take the same example. The client is looking for IP address of www.example.com. It will do recursive query to DNS server. So the DNS server will already have, uh, sorry, sorry. So it will already have a root public KSK with him, which actually comes with operating system. So it will have a root public KSK with him. So with it, so the local DNS server will go ahead and we'll do iterative query to root name server. Give me IP address of www.example.com. So now in the DNSSEC configuration, the root name server will provide you the 5 things. The first thing it will provide is a referral to .com name server. Then it will provide a DNS key record, which contains the root public KSK, sorry, public ZSK and public KSK. And the third thing it will provide is the RRSig record, which is signed with root's private KSK key. So, so RRSig is generated by signing this DNS key record by private KSK, root's private KSK. The fourth thing it provides is DS record for .com zone, which actually contains hash of .com zones public KSK. Okay, so the root's name server's child is .com, top level domain. So it provides you the DS record which contains the .com's public KSK. Sorry. And the fifth thing is RR signature, means the signed record of this DS record. okay, RRSig of DS record, which is signed using the private ZSK of root server. So once the local DNS server receives these 5 things, it first decrypts this RRSig of DNS key using the public KSK it has. Once it decrypts it, it gets the root public ZSK and public KSK. Using the root's public ZSK, it decrypts this RR signature of DS record. Once it decrypts it, it gets the DS record for .com zone, which contains the .com zone's public KSK. Okay. Once it gets that, the local DNS server's public KSK, it verifies this public KSK with the uh, root public KSK it has received from root name server. So once the public KSK is verified and confirmed, the root local DNS server can consider this response as authentic response and accept the information. Now the same thing, now in the previous step, the local DNS server got the .com zones public KSK. So now it will do iterative query to .com name server and ask the same thing, give me IP address of www.example.com. Now the .com name server will give you the 5 things. The 5 things is referral to example.com name server, the .com zone DNS key record set, the RRSig, so the DS record, and the RRSig of example.com. So as I've described in previous step, it will decrypt the first thing using the public KSK. It will get the public ZSK and public KSK. Using the public ZSK, it will decrypt RRSig and we'll get the example zones public KSK. So now it will go ahead and verify the public case .com zones public KSK with the .com public KSK received from the name server, and it will verify and accept the response. The same thing it will do. It will again do iterative query to example.com, and the example.com will provide you with the 4 things. The first thing is examples public ZSK KSK, also the RRSig of that. The third thing is actual data, which actually contains the IP address of www.example.com and RR signature of that record. The same procedure I described previously. It will decrypt using the public KSK and public ZSK, and then it will verify its own copy with the received copy. And once it is verified, it will accept this uh, information as authentic, and it will send back the IP address to the client, and ultimately the client will do HTTP request to resolve IP address. So this is how the DNSSEC works. So yeah, it is a little bit confusing, but if you can go on your own, if you have a look at this PPT, you'll better understand. You can ask me the questions uh, after this session or any time later. So this is all about the DNS. Here I have mentioned all the references which I've used. Yeah, so that's all.
Thank you so much, Omkar. We are short on time. What you can do is,
Sure.
I'm going to give you the link for the Owasp Bangalore Null Bangalore YouTube channel. There are people who have questions for you. So
Yeah,
if you can go there and answer them, that'll be really helpful. And we will
sure.
start with our next session.
Yeah, sure. On Null portal, you are saying, or
I'll ping you. I'll
okay.
ping you.
Oh,
Great.
oh, okay.
Thank you.
Thank you. Yeah,
It was a great session.
yeah. Thanks,
So
Vandana.
most welcome. So up next, we have our next speaker, Swapneel. He's going to be speaking about DNS firewalls using DNS as a layer of defense. So it's like a continuation of it, but I'm looking forward to it. Swapneel, are you speaking on mute?
Can you see my screen?
Yes, we can see your screen.
Okay. Audio, video is all good?
Video, let me see. I don't see your video. Yes, I can see your video. Yes, both are fine.
Excellent. So I think great presentation, Omkar, to begin with. I think it makes my job much easier to talk about DNS firewalls more specifically and not talk about the basics of DNS. So just before I get into the gist of things, one of the, let me introduce myself. So my name is Swapneel. I am a network engineer and a researcher as well, with interest in multiple things, more specifically DNSSEC, Unix systems, as well as security for that matter. So I'm a technical trainer as well. So I do a lot of workshops. I do a lot of hands-on workshops for which comprise for 5 days minimum. I am a AppNic community trainer as well. So I basically go to different places, different parts of the world, especially in the Asia Pacific region, and deliver these workshops for people who are, especially universities, or people who are from enterprises, as well as network operators for that matter. And I am a RIPE Atlas ambassador as well. So if you do not know what a RIPE Atlas is, I strongly suggest that you probably look into that project. And if you have any questions, reach out to me. I'll share the contact information a little while later. And probably host a probe as well. So that will be great. So if you can host a probe, that will be fantastic. I run a company as well. I primarily based out of Belgaum. So we build and secure networks for micro, small, medium enterprises, as well as network operators in tier 2 and tier 3 cities. So that's about me. I think a general outline for this presentation, from a perspective of takeaways, is going to be primarily adding a layer of defense in your network. Apart from that, I would also, focus, or rather, I would say this is applicable for network operators, applicable for even organizations of all sizes, be it micro, small, medium enterprises, be it large organizations for that matter. And it is also applicable for, home networks, right? So especially because of COVID-19, we are all working from home, most of us, most of the time. And we don't know when the situation is going to change. So this probably, this talk could be applicable or focused in the last segment which I mentioned, which is applicable for home or SOHO networks. One of the primary attack vectors in a network is multiple things. One is websites accessed, people accessing websites, people accessing apps for that matter. The second one is email, obviously, where you get a lot of attachments and content for that matter. The other is if you have a small office or a home office kind of a network, you would have something called as a file sharing. So your sharing of data between computers is primarily done by sharing folders, right? And finally our USB pen drives or thumb drives. So these are basically I would say problematic from a security point of view. So from a website perspective, there could be phishing URLs. From an email perspective, again, phishing or malicious files for that matter. From a file folder perspective, it could be as simple as a ransomware, which could spread in the entire network. And from a USB storage devices, it could be again malware for that matter. Right? But before I go to the DNS element of it, let me first probably introduce a concept which maybe is not something that is evidently known. Is a concept of a flat network. So I'm in my home right now, and my home network is basically is a flat network. So all of you, most of you, if you're running, having a Wi-Fi access point, having an internet connection, it's basically a flat network. So what do I mean by a flat network? Is a network is a flat network is something which is not segmented. So every device or every computer in the network can access one another without any restrictions for that matter. And primarily this design architecture exists is so that it's a simple way of configuring a network without any complicated configurations for that matter. So folder sharing, file sharing, data sharing. If you have a Plex in the network and you are wanting to watch a movie or put share data which is on a computer onto it, you can do it very easily because the design is a flat network. So this is how I would define something called as a flat network. So you have, a simple network where you have multiple devices. It could be computers, laptops, printers, access points, servers, etc. Problem with the flat network is, as I said, there is no segmentation of traffic, which means that propagation of malicious traffic in the network is without any restrictions, right? And as I said, a couple of examples of a flat network is a home network and a SOHO network. Now I'm going to add another element, to this, and this is primarily comes down from, serving around 100, 200 micro, small, medium enterprises that we do, is a lack of a security hygiene, right? What do I mean by a lack of a security hygiene? People in organizations will have an antivirus, installed on computers, but it's never updated, or the license is, expired long time ago. People will connect USB pen drives to a computer, and when the antivirus pops up asking for, starts the scan process, people, for the, for the benefit of saving time, will basically close the antivirus scanning process entirely, thereby, making the point of an antivirus completely moot. Apart from this, another issue that is commonly seen in networks of type, which is SOHO or micro, small, medium enterprises, is user management is something that doesn't exist at all. So the user on the operating system would log in as an administrator user, which has full privileges to the entire OS, which again has a security risk to it. And also one of the reasons why this is required is primarily because the ERP software, which is developed by a lot of organizations in, for these micro, small, medium enterprises, requires that the software be accessed or run as an administrator. And the last one is lack of an IT process. So here are a couple of examples of a phishing email. So somebody received this email which is asking them to click on a link, and unless they click on this link, what would typically happen is their account they are being informed that the account would be suspended, right? So here is a Microsoft email phishing page for that matter. So here again, as I said, so these are typical problems that one sees when you're accessing the internet. But the whole reason I put these two images as slides for that matter here is primarily to emphasize on the fact that everything begins with DNS, right? So if you're talking about even an attack for that matter, even phishing emails or malware, everything begins with DNS. Fundamentals of DNS. So this is something that I will not go into because Omkar has already covered pretty much everything about this. So this is typically just to give you a gist of what I want you to focus on is primarily the element of in the image on the left hand side you have a computer which is asking the question, what is the IP address of brainattic.in? That's my domain name. So the request goes to the stub resolver. The stub resolver sends it to a recursive, and the recursive will basically find the answer and give the answer back to the computer. And then the computer will make a connection on port 80 or 443 for the accessing the web resource, right? So I'll basically skip this part of it. From a DNS resolver perspective, before I go to that, let me just come back and probably get your attention. In the image, if you see at the very top in the center of it, you have something called as recursive DNS server. That is the one that we will be focusing on. That is where DNS firewall can be implemented. So that's the core area where I'll probably spend my energies for the next few minutes. So in the case of DNS resolver options, you have something, I don't even know if people run their own DNS server these days. When I say DNS server, I'm not talking about the authoritative DNS servers. I'm talking about a recursive DNS resolver for that matter. And most of it has become outsourced. So when I say outsourced, the core DNS providers like Google or Cloudflare or Pod9 have these recursive DNS resolvers which are accessible on 8.8.8.8, 1.1.1.1, and 9.9.9.9 respectively. Right? So these are basically free for anyone to use. And one of the reasons why people use this is because I think less headache in managing and maintaining it. I don't agree with that necessarily, but one less thing to worry about. Ideally, if you go back in the history of time, just to share this with you, in the early era of the internet, the DNS resolvers were actually run by people who were accessing internet. Then it slowly shifted to internet service providers. Hello.
We can hear you.
Yes. Okay. I just heard a blip. Just wanted to confirm that I'm still live. Okay. So so this shifted to recursive resolvers shifted to from people running recursive resolvers in their infrastructure. It shifted to the ISPs, and then the ISPs wanted to typically have one less moving thing in their infrastructure. So they basically stopped running recursive DNS resolvers, and these quad DNS resolvers is what people are known to use, right? However, I am old school, so I have been running my own recursive resolvers for quite good amount of time. It's probably the number of years is in 2 digits. And so you have open source software which can which you can install on your laptops in your network, which will act as a recursive DNS resolver. So Omkar mentioned in the earlier session that he probably specified Bind as the open source DNS software. But there are others as well. So Unbound is another recursive DNS resolver. There is Power DNS as well, not DNS, and there is something called as a Pi-hole, which I'll get to a little bit later, right? So now that we have an understanding of the scheme of things, I think it's important for you to understand that if you want to implement a DNS firewall in your network or your infrastructure, you need to first run a recursive DNS resolver. So how does a DNS firewall help? As I mentioned, that everything begins with a DNS query, be it good, good part or bad part, or more specifically, access to good domain names or bad domain names, malware for that matter. Everything is based on DNS. So DNS is used and it is also abused. DNS firewalls will basically set a differentiated route for the bad stuff. So what I mean by that is, whenever a query for a bad domain name is received by the recursive DNS resolver, it will not go down the delegation chain and find the answer. It will basically give an answer which says that this domain name does not exist, right? Which is typically something called as NX domain, right? So NX domain stands for non-existent domain. And one of the beauty of DNS firewalls is basically that it's cheap defense in the network, in a flat network especially. Having said that, let me also emphasize on the fact that from a network security perspective, this is just one layer of security. This is do not be under the impression that just having a DNS firewall is the only solution that you should be looking at. It's all a layered approach, and DNS firewall is just one of the layers of security that you can put into it. So there is so DNS firewalls is basically something called as DNS response policy zones, right? The technical name for it is DNS response policy zones, and it's basically not an internet standard as of now. There is a draft that is currently available. So in the references slide, I have a link for that. So if you are interested in reading the entire draft, especially if you're interested in reading RFCs, then I would highly recommend you look into that as well. So it's a vendor neutral distributed DNS firewall. So it is not dependent on any specific vendor. It works for Bind, it works for Unbound, it works for, I think it also works for Power DNS as well. Not DNS, I'm not too sure about it, but I think I'll check that as well. So the draft is by Dr. Paul Wixie and Shriver. I'm forgetting the first name, my apologies. And having said that, it's Dr. Paul Wixie's birthday today. So Dr. Paul, wish you a very happy birthday. Have a good time. So it's not as I said, it's not a standardized ITF protocol yet. Uh, it allows policies to be applied to DNS queries. So when you have, when clients in the network send the recursive resolver, queries, uh, what it will do is it will, based on the policy, it will give a differentiated answer. So it will not, it can give a different answer to different clients based on what the policy is configured. So this is the gist of it. Any firewall for that matter is depending on something called as a trigger, and based on the trigger, then you have something called an action for it, right? This is how all firewalls typically work, irrespective of it is a software firewall or a hardware firewall. And there are different triggers that are available here. The first one, let's say, for example, if I focus on that, is something called as queue name. So that is query name. So which means that if the query name that the client is requesting is, let's say, brainattic.in, right? Then have an action for it. So the action could be, drop it entirely, uh, pass it through but log it, or maybe give an answer that the domain name doesn't exist. But in reality, on the internet, there could be the domain name which is resolving, right? But the recursive resolver that you have in your network is basically giving a differentiated answer. This is something that I think Omkar already covered a while back. So this is a sample DNS zone file. So this is how um, the DNS data is stored in a flat text file for that matter. What you have here is basically an example of a DNS RPZ, that is response policy zone file for that matter. So if you see, if you just focus on, let's say, for example, the first element, which is addservice.google.com.vn. And Omkar mentioned earlier that CNAME stands for canonical name. So what we are saying in the zone file is when a client machine or a client device in the network makes a request for, let's say, addservice.google.com.vn, give a NX domain. So the dot stands for give a NX domain. Right? Here is how you would typically specify the zone file, just as any zone file in a DNS software, which is maybe bind or unbound or anything for that matter. And this is how you would specify that this is a response policy zone. So this is not a normal DNS zone. This is not an authoritative zone for that matter, but this is a response policy zone, right? And with that, I think I will move on to showing a quick demo, and I hope the demo gods are with me today. So I'm going to try my luck. So I'm going to take you to the terminal. Can somebody confirm if they're able to see my terminal screen?
We can see, but if you can zoom, then it'll be more better. Like
Sure. Does this work?
this should work. Yes.
Okay, great. So what I've done is I basically let me just run you through the DNS setup that I have. So I'm running bind here, the latest version of bind, and let me open basically the named.conf file, and this is basically the standard file for that matter. But if you see, as I mentioned in the response policy, I'm mentioning a zone, and I've given a name fish.host.ttq. It's basically a zone file from one of the threat feed vendors for that matter. And let me show you. Right. So this is where it is defined. And it basically contains all the you can say domains which are related to phishing. So just to show you an example, instead of hunting down for a specific example, what I've done is I've taken three domain names, three domain names which are basically bad. So when I say bad, they were used or they are being used for phishing content for that matter. So if I take this example, what I'm going to do is I'm going to use the 8.8.8.8, which is Google DNS server. And I'm going to send the query for this specific domain directly to 8.8.8.8, right? So when I run that, you see that I'm getting an answer, right? I'm getting an answer which says that IP address, that is IPv4 address of the domain name is 162.210.70.147. Right? So this is something that DNS firewall will prevent now. So what I have done is in the DNS configuration which I have done, I have said for this domain, serve a non-existent answer. So if I do that, I'm sorry. Okay, this should help. So I'm running a recursive DNS resolver in my network, which is on the IP 192.168.0.250. So when I run this now, you see that there is no IP address section that you see, and you see the status as NX domain, right? So what happened here was the query from my machine, my MacBook, went to the recursive DNS resolver, which is basically giving me a differentiated answer. And this is irrespective of the fact that the domain actually resolves on the internet, right? It's based on the response policy zones configuration, which exists in the DNS software. My recursive resolver is giving me a differentiated answer, right? So similarly, if I have to take a few more examples, this is one more domain name which I could find, which is basically being used for phishing of Apple for that matter. So if I take, say, for example, 8.8.8.8 again, you see that the domain resolves, right? But if I do the same thing and I send it to my DNS resolver 192.168.0.250, you see that it gives a NX domain, and you can also basically look at the logs. That is something that let me show you that. Right. So for every DNS query that I make, which is something that it would give a differentiated answer, it would log the answer in the log file. So you see that from my machine. And so this terminal, so that the terminal what I have here, which is tailing the log file, is basically my recursive resolver. That is that machine. So you see that there was a request from the client 192.168.0.190. And the query name, the answer is supposed to be given as NX domain. And that's the reason why that domain doesn't resolve for me. So let me go back to my presentation. So you have, so basically you need something called as, in order for you to configure a DNS firewall, it cannot be that, you populate these domain names one by one. You can do that, of course, but additionally, what also helps is something called as reputation feeds, right? So these are basically community driven, as well as some are paid, some are completely free. URL House is one which you can completely, it's a community initiative. So you can go onto their website, search for DNS response policy zones, and you can basically configure their feed, right? Serval is another, spam house, Farsight security, switch, or you can also create your own feed, right? A couple of things that I wanted to mention here is you need to be very specific when you're configuring this, is because you have to look out for false positives. So say, for example, mistakenly, if you put something like facebook.com or instagram.com and you are at home, you are basically going to get hammered by a lot of people who are going to complain to you that this stuff is not working in the home network, right? So you have to be very careful about what domain names you put there. Monitoring and analysis is something that is very easy to do, especially if if you look at the log files, you have a pretty good picture about what is happening with regards to what is being blocked, what is being allowed, etc. Another fun thing that you can extend this DNS firewalls is to primarily use the ELK stack, and take the log file and parse it and basically have pretty charts for that matter. So one of the key takeaways which I would highly recommend all of you is primarily to run your own recursive resolver, and if you're already up for it, then start looking at how to run DNS firewalls for that matter. I'll share references. I will share contact information in case if you have any questions regarding that as well. So one of the simplest things, so I've been, as I said, as I mentioned, I run my own recursive resolvers. So I do it not only on my networks, but I run a recursive resolver on my laptop as well. So even when I'm not in my home network or my office network, there is a recursive resolver which is resolving all queries and stopping all bad domain names from being resolved. Another fun project which I will point you to is basically something called as Pi-hole. So the Pi-hole is basically nothing but a DNS server on a Raspberry Pi. So that is something that you can explore. It provides a nice GUI interface where you can actually see the amount of DNS queries and the amount of queries blocked and something like that. And for a long time, the only way the Pi-hole used to work was it used to be a complete network-wide blocker, right? So it used to block. This is not DNS firewalls for that matter. Pi-hole is completely different. But in case if you want to first get your hands dirty with respect to something that is a little more simpler, say for example, then I would highly recommend the Pi-hole, especially for people who are not technical. If you're going to run it in a home network or going to set it up for other people. So version 5.0, which came out, I think, a couple of weeks ago or 1 week ago, basically has the option of blocking or allowing DNS requests based on the client, who is asking. This is something that is very similar to DNS firewalls. Of course, DNS firewalls or DNS response policies zones do much more than that, right? Current challenges. This current state of DNS is unencrypted. It's also called as DO53. That is DNS over 53. So quite some time back ago, a new protocol was standardized, which is DOH, which stands for DNS over HTTPS. The RFC is 8484. I did a presentation a couple of weeks ago at the RFCs. We love virtual meetup. So I think in the references, I have a link for the YouTube as well as my slides as well. So if you're interested in learning how the protocol DOH works, so maybe you can look into that as well. So in the gist of it is the browser basically will not send DNS queries unencrypted. It will directly send queries over HTTPS, that is the transport. So what it means is if you're running DNS firewalls or if you're running Pi-hole in the network, then, and especially if you are, let's say, using Mozilla Firefox and you're in the United States right now, then your DNS queries are not going to your recursive resolver at all. They are directly going to, probably somebody like Cloudflare or, some other option. I think NextDNS is the other option which Firefox has. So the way Firefox has basically implemented is basically opt out. What it means is you need to explicitly opt out of this. And this has been rolled out for everyone in the United States at this point of time. Google Chrome has announced the way in which they are going to implement it. And I think in the case of Google Chrome, considering that they have a lot of enterprise customers, this is going to be an opt-in. So enterprises or networks will will have an option of disabling it for that matter, in case for whatever security policies or if they are running a DNS firewall or something like that. Brave is something that another worthy mention. I've been using Brave browser for some time now. So here also the choice. So Brave is based on Chromium, and the option is opt-in. So you have to explicitly opt in for enabling DOH at this point of time. Windows 10 has also announced plans for DOH. So in the case of Windows 10 as well, what is going to happen is the option is going to be given to the administrator to configure it. Few references. I think on the null website, I have already uploaded my presentation, so you can download it from there, and you can look into configuring a DNS firewall, or look at all the references which I've given here. And I think with that, I will conclude, hoping that I am well within the time frame. And here is my contact information. So I'm available at Twitter, as well as you can send me an email in case if you have any questions with regards to DNS firewalls. And before I hand over back to Vandana, I would also like to mention about RFCs we love. So if you are interested in protocols, in requests for comments, that side of things, then I think I would suggest you to join the group, and this is how you can do it. So there is a mailing list for this, and there are handles for social media as well as email as well. There is a WhatsApp group as well. So if you're interested, you can sign up. With that, I think I will take this opportunity and thank you all for being present on a weekend and listening to me patiently. And hopefully, I have convinced you to run your own recursive resolvers and configure DNS firewall. Thank you so much.
Great. Thank you so much, Swapnil. And there are a few questions you can actually check in the chat box.
Sure.
Great. Thank you. So now up next, we have Ashok, who's going to talk about HTTP request smuggling. So Akash, over to you. So he has a very interesting name, Raavan.
Okay. Okay.
Yeah.
So hi guys, myself Akash Ashokan. I'm basically from Ahmedabad and I'm a security researcher. So this is my first time trying to explain HTTP request smuggling. So I hope you might accept my apologies if there are any hiccups. So let's go with the presentation. I say. Okay. So we will start with the presentation on the part. So if we are going with HTTP request smuggling, so HTTP request smuggling, what is it? Let's say if in case there are certain things we need to understand before going with the HTTP request smuggling concept, like RFC specification, the content length transfer encoding, front end, what is a front end and back end server, okay, and CRLF. So what happens over here is, whenever a HTTP request is originating from the client, okay, so there are more than one entities. It is written over there as more than one entity, like their front end server as well as a back end server, okay. So what happens is, when we use, let's say there are multiple requests going on, like it's similar to what I would say. Uh, if it's in a request, there is a content length as well as transfer encoding. So in case, if, in the RFC specification, okay, in the RFC specification, it is specified that if content length and transfer encoding, they both go hand in hand, the server is supposed to accept the transfer encoding and bypass the content length parameter, okay. The content length header has to be bypassed. So when that comes into play, okay, so let's say it went to the front server, okay, it accepted the transfer encoding or the content length, one of those would be accepted, and it goes to the second server, okay, the backend one. When it reaches over there, what happens is, what is HTTP request smuggling? We are trying to smuggle a request inside another request body. So let's say, what are the causes that happen to have let's suppose, what causes HTTP request smuggling? So the first part is, in the protocol design before HTTP 1.0, every time a client makes a HTTP request, it needs to establish a TCP connection with the server. So the modern websites are composed of multiple resources. Let's say we need to obtain a content of a web page, not only the request HTML document, but also various contents such as JavaScript, CSS, and images. Okay, so it will cause the load overhead of the HTTP server to increase. So there were two other things introduced, called as keep alive as well as the pipeline. Okay, so what keep alive does is, the keep alive is by default HTTP 1.1, allowing multiple request and response to be hosted on a single connection. Let's say, what I would say is, suppose I have multiple requests queued in one go. So what if the all the requests, if every time it tries to establish a new connection, it will be a long process and the website would lag and would be slow. So what Keep Alive does is it keeps the connection alive, okay, and tells the server that not to close the TCP link, okay, and tries to perform the TCP handshake process so that the server load is less, as well as the resources and the speed is increased. Okay, the resources are saved and the speed is also increased. And with pipeline, okay, so the HTTP request, without waiting for response from the server, after receiving the request, the server needs to follow the first in first out mechanism. Let's say the first request came in, okay, so the first in first out mechanism depends, like the first request has to be processed and the response has to be forwarded and the second request is being processed, okay. But the browsers nowadays don't support the pipeline by default, but the general servers provide the support for pipeline over the server side. So the first part was, let's say the first part to be was Keep Alive as well as pipeline, and the second part is transfer encoding, which comes with the let's say, in explanation to what I would say is, like, in transfer encoding, we mainly focus on the chunked encoding. And what chunked encoding is, it is usually used to bypass the WAF. Okay, let's say it's like, if I'm trying to send a chunked encoding, okay, so in chunk what happen in transfer encoding, what happens is, there is a series of requests inside the request message body. The content length, what we specify as content length, the transfer encoding, it is right above the content, as well as it's in hexadecimal format, okay, which I'll be showing you in practical, because in theory it is a bit tough to understand. uh, so let's see over here the transfer encoding part. See, what you can see over here is there's a post request, in which I would say is post request, and here is the transfer encoding chunk. So what I wrote over here is wiki, which has, it has the character length of 4. So I had to specify 4 over here. Then I wrote over here is pedia, which means there are 5 characters in it. So the content length went on to 5. Okay. So the same way, the in transfer encoding chunk, just right above the word, the character encoding has to be specified, and the which means its length. So in let's say in HTTP request smuggling, we know that the content length, I spoke of before, that the content length and the transfer encoding can be used as a way to process the body during the post data transmission. So let's say the front end server is trying to only uses the content length header, and the backend server only uses the transfer encoding header. What happens over there is the front end server accepts the content length. It accepts the content length and passes on the request to the backend server. What happens over there is the backend server accepts the request where we have used a delimiter called 0. What happens over there is anything after the 0 is been cached to by the backend server, and when the other request comes in, okay, the next request, the following request comes in, the part that has been kept back by the backend server is appended in front of the other request and is fed onto the server. And the same thing happens with the TECL, which is transfer encoding header, and the backend server is using the content length encoding server. Uh, let's try with an example. So it would be more helpful to understand. I'm going to use burp. Okay, I'm going to use burp port trigger for explaining this particular vulnerability. Okay, so we have the page over here. What I'm going to do is I'm going to get the request. So we have a page. Now what I can do is I can go to the repeater, I can forward it to the repeater, and let's see what response I'm going to get. So I've got a 200. Okay, so what I can do over here is, so here there is no content length. Why there is no content length? Because it's a GET request. Okay, there can't be any, there is no message body in order to show the content length. Okay, so what, and the other part is, in order to get HTTP request smuggling running, the server has to accept a post request. Let's say I'm going to turn it into post request, and again I've received it, but there is still no content length because there is no data. Let's put in some data over here. Let's say 0 and G. So I have got a content length of 6. Now it got me a content length, it has a 0 and it has a G. Now what is going to happen next? Let's see. Now we have, now we will, what we are going to do is we are going to paste it directly over here in our request. Let's say, yeah. Okay, so what it does is, it is going to, by default it is going to send it to the server. As soon as I send next, it has given me an output of unrecognized method gpost. See, you can look it into the response that unrecognized method gpost. What does it mean by unrecognized method gpost? As soon as I clicked on send, what happened was it sent this particular part of the request. As soon as it reached the part 0, it said the request has ended, and the server, what it did was it processed this part and gave me a response, a perfect response. But what happened to the G? The G was on the backend side, as I would say, it would be in a way cached over there. As soon as I'm sending the next request, okay, the G got appended in front of the post, okay, like this, just like this, the G got appended in the front of the post, and there are no HTTP methods called gpost. The server couldn't recognize this part of the request. So what I can say is, let's say if it's a GET request, what if I used a GET request and I'm trying to do HTTP request smuggling? So a GET request cannot contain a body. It will always give you an error. So whenever you're trying to do an HTTP request smuggling, always make sure that you're trying to use a post request over here. Okay, so when you find a request, okay, so what all you have to do is you have to go to the request and change it to post. Okay, add a transfer encoding chunk and a delimiter 0, as well as you have to paste some part of it. Let's say I can write X as well, I can write G as well. So what is the use of it? Why I have written a G over here? What if I wrote a complete new post request? If I wrote it over here, it would have executed on the backend server side on the next request, which will be, we will be looking onto it in the further part of the session. Let's just say we successfully did it. So right now we know that there is HTTP request smuggling, but how to exploit it? So this part, when it came to this part here, the content length is how to know whether the content length is being monitored or not. So let's say we are trying to play with the content length over here. So I tried manipulating the content length, but the repeater again refreshed it. So we always have to go ahead and go to the repeater and stop the update content length part. If you don't do that, the content length will be updated every time the request is being sent. So let's say, Okay, let me refresh it again. Okay, so see, when I use content length as 5, the request is taking longer period in order to get back to me. As well as, see, so on this side, what happening over here is the content length is being monitored, and because of we have changed the content length, it not able to read the G, the capital G part. Why it is 5 while we have only 2 content over here? See, so that's why I explained about the CRLF, like /r/n, okay, and mm, /r/n. So what happened over here is it is 1, 2, 3, 4 and 5 and 6. So that why there was 6, the content length was 6, and because of that, when we did it for 5, it is only reading till the line number 15, and it won't be going after with the G. Let's say we are increasing the content length and we are trying to exploit it. Okay, so there is no response coming from the server side, like it's pretty slow. Let's go with, again, let's go with 6 and try it again. Okay, send. Okay, so this is how I can confirm that the content length is being monitored on the front end server. Okay, the front end server is accepting the content length part, and the backend server might be accepting the transfer encoding. Okay, so that is how we confirm that this particular attack is CLTE, HTTP request smuggling. So if I explain it in detail, let's go with this. If the first part we tried was the get request. The get request, what it gave us was get request cannot contain a body. So the HTTP request smuggling attack has to be a post request. Okay. The second part we receive is when we are appending a post request, we have to make sure that the repeater doesn't update the content length in order to check whether the content length or the transfer encoding is being accepted by the front end server. Okay, so once we did that, okay, it gave us on the second request, it gave us a G post error because the G over here was appended in front of the post request, and it tried to execute it, but there is no HTTP request method called G post, so we could not get a valid response. So it gave us a 403 forbidden error. Okay, so let's go with this part. And now let's just say I'm going to use the other method called the basic TECL. So let's say what can we get from that particular attack. Let's check it out. See over here, what I can show you is, let's copy the whole request part. Okay, what does it mean? Let's explain that in brief. Request 3. See over here, there is a we are saying we are trying to exploit it, and we are trying to check whether the transfer encoding part is being accepted or the content length. So how to find it? I again explained it. If I am receiving a transfer encoding as the first request. Let's say the transfer encoding is being accepted by the front end server. Send repeater, and let's go with this. Let's change it to post request. Then let's copy the whole thing. Okay, now let's say update content length for the first part. First part content length 99. Okay, now the second part, third part. Okay, now let's say remove the content length part and let's try with 90. And still here we are missing something, the transfer encoding part. So let's copy it up and paste it. Okay, so let's give it a go. Okay, so we are getting a read timeout error. So there might be some error with our request. Let's try again. Read timeout error again. There is some mistake with the labs over here, I suppose. Let's do one thing with it. Let's copy this request because there is some error with the part over here, I believe. Okay, we have to copy the part. Okay, there is some error. Let's try again with the proxy intercept on. Send to repeater, and let's take the payload from over here directly. Maybe there is some error with our copy and paste. We did it. Post repeater, update content length has been removed. Send. Okay, we are getting a request timeout error again and again, which is not good. Okay, so there might, it seems that there is some issue with the lab itself because it is not, I'm not able to do it. It is not giving a response, a proper response, and it is being like it's giving a read timeout error. Let's try it. It should be one. let's update the content length on one side and let's try it. Seems there is some kind of error on the server side. Let me explain you about this payload, why we've been using the 5C over here. So let's go with that. Okay, so why 5C? In transfer encoding, the content length, it's like the content length. Let me show you. It's kind of, okay. So it's kind of, let's just say, go to the decoder, paste it, decode as hex, which is 92 over here. Okay, so it is nothing but the content length of the particular message body. Okay, so I believe there is some kind of error that is being placed over there. Let's just see to it. Should not happen, but okay, so I believe the labs, the TECL lab is like it's malfunctioning somewhere because it is always giving me a read timeout. So I believe we must go with the other part of the lab because we are still, again, we are on the lower side of the timing. Let's go with the other part where we will be exploiting. Let's say, okay, so let's say we need to exploit it using the burp add-on. Let's say we have to automate the attack. How would we automate this particular attack? So let me show you how to automate this particular attack by using burp itself. So for this, we actually need two extensions called as the HTTP request smuggler as well as an extension called flow. So what exactly HTTP request smuggler does is it tries to probe the same thing what we are trying to do manually. It is automated and it does the same thing over with multiple requests and it tries to fuzz it. And with flow, what exactly flow does is flow, I have actually set this particular flow in showing in show only in scope attack or show only in scope, as well as I'm only told it to show the request being sent by the extender, like whatever request that is being submitted by the burp, all the requests can be shown over here as a series. It's like in a sequence, it will be shown over here and the responses can be shown over here as well. So it is much easier, okay, much easier to go through the whatever attacks or whatever requests are being sent. And in that way, this is the flow is very useful for attaining and know how to exploit the HTTP request smuggling. Okay, so let me show you this part. Let's get a fresh request. Let's get a fresh request. Let's say refresh. Okay, what I'm going to do is send to repeater, intercept off. Let's right click and there is this particular option called launch smuggle probe. So there is this OK. In many of the systems, the OK won't be visible. So I would prefer don't click on anywhere, just press enter. Okay. As soon as we do that, the smuggle probe will start probing. Okay. It will take some time, but it will start probing with the request. Okay. So here we are getting a post request of 403. Okay, so there's forbidden duplicate header names are not allowed. So this particular attack, this particular error, I'll be showing you in the last exercise of our attacks. Like, why is it showing the forbidden duplicate header names? So here we are receiving a 200 OK response. So we will have to wait for some other response header which actually says otherwise. Okay, so it takes some time, okay, but it gets you the results. So we will have to wait for a few seconds in order to get a response. See this part, the request, many of the requests you will be seeing the transfer encoding as in a different formats. Let's say here chunk space identity is written over here. In some other requests, you will be seeing two transfer encoding headers with one belonging to chunk and other belonging to identity. That is one of the reasons in order to, let's say, bypass the WAF, okay? In some places, the WAF would block the chunk part as well as one of the transfer encodings. So in order to bypass that, two transfer encoding are being introduced into the request so that in order to bypass that particular vulnerability. Okay, so let's say, see, we have got one request which says 400 request is invalid request head. Let's go with the other one. So we are getting some 400 requests, 400 status codes response. So let's check with it. So it's going, as far as now it's going fine. And in the meanwhile, just keep on checking the target part, that if you have received any of the probes for HTTP. See, we have got one possible HTTP request smuggling CLTE over here, a delayed response. So let's go through with this. Okay, you have received this particular request. Okay, so here it is. The request 1 was being sent with a 0. Then the response received was a 200 status. Now the second is being sent with this part and the response is invalid request. Now what happens with the third is, the third gives out an invalid server error. Okay, the same request has been sent twice and two different responses are being received. Okay, so what happens over there is the backend server is let's say it is trying to append whatever is being sent to the request with the request and feeding it to the server. So now as we have this particular request which is vulnerable, okay, let's go back and try smuggle attack CLT, because the possible attack we received was smuggle attack CLT. So we will be launching a smuggle attack. Now, in this particular smuggle attack, what it does is it would try to send a GET request for a 404, hopefully 404. Okay. So when this is completed, when it ends, what would happen is we will be receiving a 404 response. If the server is not vulnerable to 40 this HTTP request smuggling, then we will never get a 404 response. If it is vulnerable, we will always get a 404 response in the response. Okay, so let's do this. It will take some time and it's trying to fire. So see, we have received a 404 response code. That means this particular server is vulnerable to HTTP request smuggling. Okay, so it sent a request and we received the 404 not found. So this is how you can automate the attack. Okay, you can automate the attack and use it for use it wisely. Like if you are trying to do it manually, it might take a lot of time. Like you will have to obfuscate the attack and all those things. Many of the other things like chunked encoding has to obfuscate it, tried with different white spaces. So it might take a lot of time, but if you're trying to automate it, it will be really helpful. And the burp this particular burp extender add-on is very helpful with this. So we have received the CLT part. So we now know how to, let's say, how to exploit this particular vulnerability. Now we are going into exploiting it in a, let's say, environment. I cannot show you a real-time environment which I have exploited, but I will have to show you with this particular smuggling lab itself. So let's go with this. And there is this request smuggling to bypass CLT vulnerability front-end security. Okay. So what it says is over here, it is trying to say that I will have to find the admin panel, okay, but the front end server blocks access to it. So let's just say I'm trying to write over here as, let's say, /admin, and if I do it, press enter, what happens is it says path admin is being blocked. So let's go back, okay, go to burp suite, let's clear all our request part, and otherwise it will be havoc when everything is being mixed up. This doesn't work. It is not deleting, or it is taking a lot of time. Let's go with another burp of our own. Proxy options, intercept off, proxy options, intercept on. Let's close this guy over here. Let's go with this part. Okay. So what I can do over here is I already set up the request and acceptance thing. Let's go and press enter. We've got the request. Let's send it to repeater. Okay. The repeater and the connection close. I have to change it as keep alive as we spoke before. Now, what I have to do is I have to send a request. Okay. I have to send a request which will be having a smuggle request requesting for the admin panel, admin page. Okay. So let's try with that part. I'm going to copy this particular request and let's take the content length as well. Okay. Let's say I took the content length, repeater. Uh-oh, here it is. Okay. So let's paste it over here and let's see what's the response. So I've got a 200 okay response. Okay, so let's try it again. Let's try it again. Invalid request. Okay, so it gave us out an invalid request. But what about the admin page? We didn't receive it. So there is some issue of getting our request on the other side maybe. Okay, so let's go with the other part. Okay, let's append a host, because sometimes, okay, sometimes it has to be merged with the host header of local host, and we have not specified any host over there. Sometimes the admin page has to be accessed using the local host. Let's post it over here and let's send repeater update content length. Okay, it's fine. Okay, the content was getting updated. Let's get an error with this. 38, no, Let's try this. It's not giving me any response. Let's go with 39 again. Cancel, send. Okay, we are not getting a response. Okay, so we again got a read timeout error. Okay, so let's go with this.
Akash,
Yes.
almost we done time for you. I think if anything is their conclusion, I can finish it up.
Okay. So what we can do is, let's just say if I append the host header over here as local host. So what happens over here is when local host header is being added, it happens, so it will again give you an error because this particular request is being appended in front of the other request. It will give out an error as different same host, two different hosts cannot be in the same request. So you will have to pose it as a parameter. Okay, you will have to convert the other request as a parameter appended behind it. So what happens is this particular request is would be executed over there. Okay, and you will get the output. And using this part, you can always execute other vulnerabilities that are being conducted, like XSS, web cache poisoning. All those kind of requests can be done using this particular HTTP request smuggling attack. Okay. And I'm really sorry, guys, because of the hiccup with the labs part. I have no idea what happened to this lab. I tried it twice this morning, but it worked. Now it's having an issue. I really apologize with the null and Owasp group. I'm really sorry. Thanks again. Have a nice day.
Akash, that was a great session. No need to apologize. We had to be glad to that you are presenting a very good sessions to us. So it's only reason the time durations only, nothing else. So as per the time we had to be complete the person talk. So
No issue.
anyway, it's very nice session. Thank you so much for
Okay.
contributing to Null and Wires. Thank you. Vandana, we'll go for conclusion or will.
Great. Thank you so much, Akash or Raavan. So, uh, and thanks to all the speakers for joining us today. We have tweeted the next month speaker form. So, whoever is listening, please do fill the form if you want to speak at the next Null and Owasp meet. We will be sending out emails as well. We will be we will keep it open for next 1 week, and as soon as we have the required number of people, we will close the form. So please do submit your speaking slots, the topic of your talk now, and we will discuss with you. If you want that, you're not sure whether you'll be able to deliver or not, but you want to give it, we are here to mentor you. So make sure you submit. We will reach out to you. We'll be connecting you. We'll be mentoring you. We'll be guiding you through the whole process. And similar way, we will also be posting the dates for the next month. It'll be an open poll, and whichever date is selected by the maximum people, we will take it. So it's all a community-driven event, and we look forward to the date and the speaker. If you have any questions, please feel free to reach out to us. Thanks everyone for joining us today. Have a great day.